Class, today we're going to learn about space exploration. How do we get all this information about objects in space, about all our planets and their moons, etc.? There's a lot of things that go into our exploration of space, a lot of things that are calculated when doing this, and a lot of things that are determined. And I just want to talk about a few. Now, remember, if it's in blue font, you don't have to write it down, and you'll find out that on this note sheet that you're going to be filling out, there is absolutely no space on this note sheet to fill out this stuff that I'm giving you right now. So don't worry about it right now. The next slide, then you'll start writing stuff on this note sheet. Sweet? All right. When we send humans into space, it's a gigantic risk. If you think about NASA, they've been operating for over 50 years, and they've had something like 16 fatalities in over 50 years. And there's not many professions where they can say that. So there's a really high risk from people being in space because there's no air, there's no water, there's high radiation. They can get hit by micrometeorites. There's all kinds of things that can happen. Our current technology limits the distance at which we can travel to places and safely do that with humans before they run out of oxygen or food or water. That we have limits there. For example, right now, it would take roughly 90 days to get a human being to Mars, and then they would actually have to stay there for almost close to 2 years, and then they would come back. So that's a pretty significant leap. We're getting close, but some of that is problematic. We have sent people to the moon. That's the only place outside of the Earth that people have been to, and only object that they've landed on, human beings, and we send them into Earth's orbit in spaceships or in the International Space Station. That's where people have been to. If we send unmanned spacecraft, these are basically robots. They're safe. We don't have to feed them. They don't need water. They don't need food. They don't need protection from radiation. They don't need air, all these kind of things. So, and nobody dies if a spacecraft crashes. So those make them all very safe. They can travel long distances, they can go very fast, and they can spend long times in space, which humans currently cannot do those things. So this is why we use robotic spacecraft. So let's talk about some of those specific types of robotic spacecraft and what some of the differences are between them. All right, this is the point now where on this worksheet, you're going to start filling out stuff on this worksheet, okay? Filling in those blanks. So the first type of spacecraft we're going to talk about is what's called a flyby, and that's exactly what it sounds like. It flies by an object, whether it's a planet or a moon. It's really easy to do. It's kind of like if you throw a log into the lake, you can throw a rock out there and get it close to it, and that's all we're trying to do. And the reason why is because then we get much closer images. Even if they're from 25,000 miles away, they're much closer than they are from Earth, where they're millions of miles away. So we get much better detailed information by sending a spacecraft near them. A good example is the Voyager spacecraft, which launched in the late 1970s and went and looked at the outer planets. And so some of our very first close-up images, and to this day, some of our only close-up images of some of the outer planets have come from the Voyager spacecraft. It was actually two different spacecraft, Voyager 1 and Voyager 2, and they are still traveling out into space, and they have been for 40 years. And it took them over 40 years to actually get outside our solar system, traveling at 25,000 miles per hour. So that tells you our solar system is really big. The next one is an orbiter. Orbiter different from a flyby in that it will end up going around and around and around an object, usually for years and years, and sometimes close to a decade. And because of that, they get to see the whole planet, and they get gobs and gobs of data on the planet because they spend so much time there looking at it, studying it. The example you have here is the Cassini spacecraft. This was an orbiter of Saturn. It spent 10 years or so in orbit around Saturn. It studied a bunch of moons. It discovered a bunch of new moons. It dropped a probe onto Saturn's moon, Titan, parachuted through the atmosphere, and gave us our first close-up images of the surface of Titan, and studied the atmosphere, etc. It also eventually, when it was wearing out, they changed its orbital path so it flew through the rings of Saturn and between the rings and the planet itself before they actually crashed it into Saturn, before they lost communication with it. It was a 3-story satellite, very huge satellite, powered by nuclear power because there's not enough sunlight out at Saturn to power it with solar panels. The next type of spacecraft is a lander. The difference between a lander and the other ones is it actually goes down to the surface of the planet. That's awesome because then we get really close-up images of what's on the surface. In the case of most landers, they have some sort of robotic arm or something that allows them to contact objects around them and do some physical study of the area around them and take close-up images of the surface. The drawback is that if they land in this spot and they're like, well, that spot over there looks really cool, they can't go over there because it doesn't move. But we can still do some neat things on the surface that we can't do with an orbiter and we can't do with a flyby mission because it's actually on the surface of the planet. So the example here is the Phoenix lander, which landed near the North Pole of Mars. And essentially, they were sending it to look for, to see if it could determine if there was water ice in the soil in that area of Mars. And it did find water ice in the soil there in the time that it functioned. So cool. Can't really do that with an orbiter or a flyby. A rover, its advantage, it lands on the surface and then it can drive around. So if it sees something cool over there, it can go over there and it could go back this way and go that way and go over here. So they can cover a lot of ground. And we've put them on the moon and we've put them on Mars. The Sojourner was the first rover to land on Mars. It was the size of a microwave, and it could drive around a little bit and butt up against a rock and analyze the rock. But we actually proved that we could drive a rover on another planet with this one, which is kind of sweet. The last one I'm talking about is what's called a sample return, and that's exactly what it does, is what it sounds like. It goes to an object, it collects a sample, and it brings it back to Earth. So we've done this with asteroids, with comets, with solar wind particles. We have yet to return any material from another planet using this, but we have plans to do that with Mars and potentially some other objects. So this example here is the Stardust, and it flew behind a comet in the comet's tail, stuck out this little arm, and collected material in that collection device, pulled that back in, and then parachuted that back down to the surface of the Earth. And then scientists were able to collect that and study what the material is like directly in the tail of the comet. So kind of neat, aggressive missions. All right, ladies and gentlemen, what you're going to do today, we've got this assignment right here. This is going to use some pages from the old textbook or the one that's in the back of the classroom, and you're going to answer questions on this about some of the spacecraft that have studied our solar system. That is what you'll be turning in. Awesome.